Welcome to the iBwave webinar on the coexistence of wireless technologies in campus environments, featuring speakers from CommScope and ATT. My name is Elsa Levy and I'm part of the marketing team here at iBwave. I'm very happy to see many participants with us this afternoon, and I thank you for joining us today. So before we begin, I'd just like to go over a few housekeeping items. So first of all, I'll be sending a copy of the presentation as well as a link to the video recording of today's session via email tomorrow, so you can watch out for that in your inbox. Secondly, you're welcome to use the GoToWebinar question panel to ask questions at any time during the session. We'll try and answer as many as we can during the last 10-15 minutes of the session, whilst time allows. Also, for today's presentation, we will use the GoToWebinar polling function so that we can get your feedback on different aspects of the presentation. We will have 3 different questions for you this afternoon. So essentially, when the poll pops up, you can simply click on your desired answer, and we're going to tell you the responses instantly so that we can share them with you. Lastly, for those who might be experiencing audio difficulties, we will try to speak as clearly and loudly as possible, but please make sure to check your own audio setting on your computer or your phone as you dial in as well. So for today's presentation, we're happy to have 3 speakers. To kick off the webinar, we will begin with iBwave's Chief Technology Officer, Dominique Gauthier, who will talk about the demand for wireless systems inside campus environments and provide us with some high-level statistics and trends on the subject. Our second speaker is Patrick Lau, Director of Business Development for the Americas region at CommScope. Patrick will cover LTE and provide an overview of the market, as well as the various DAS coverage options inside campuses. He will then talk about the best practices for capacity planning and the lesson learned. Our third and final speaker is Tisha Wilson. Tisha is the Area Manager Construction and Engineering for AT&T's Antenna Solutions Group, and she will present various solutions for campus environments, as well as the standards and requirements for success and construction lessons learned. So we have a lot of great content for you today, and without further ado, it is my pleasure to introduce our first speaker, Dominique Gauthier. Dominique has been in the telecommunication industry for more than 15 years. He joined iBwave in 2005 as the CTO. His role is to oversee all aspects of product development as well as new product architecture. Dominique has been focusing on providing clients with high-quality in-building wireless solutions, turning their satisfaction into customer loyalty. Some of his other priorities are to continuously develop R&D, oversee technical opportunities, and ensure excellent product reliability. So Dominique, over to you.
Thank you, Elsa, and good afternoon or good morning, everyone. Today is quite interesting to see the number of participants. So we have close to 1,200 people who registered to our webinars. I'm saying webinars because we started our first session to cover Asia Pacific last night. We're doing a session this morning, from a North American perspective, to make sure that we serve and address our customers in Europe, Middle East, and also Africa region. And then later on today, we'll conduct a third one to address North America as well as Central and Latin America. So we have registrants from more than 70 countries. So we can see that this is a topic that generates interest, and hopefully you find the webinar informative. So before I get into the subject matter, let me briefly introduce iBwave as a company. So first, my name is Dominique Gauthier. I'm the CTO and co-founder of iBwave. And our company offers software solutions that you can operate on mobile devices like your smartphone or tablet. You can also install some applications onto your desktop or your personal computer, as well as we have server applications. But basically our tools are mainly used to plan, design, dimension, document, and also operate wireless and building networks. And that also goes outside of buildings, such as university campuses. So we have a presence in over 85 countries with more than 600 customers. So today we're very happy to share with you and have guest speakers from CommScope and AT&T to share with you their views and their experience of how these type of deployments on campuses goes. So before we get into the specific subject, let's look at market indicators. And on the left side, we're relying on the most recent VNI market analysis from Cisco. And according to Cisco, different indicators project continuous growth in the wireless industry. And then we'll look at specific in-building market afterwards. So whether we look at the number of mobile users that is continuously growing, the quantity of 4G phones or tablets, the quantity of applications that are being downloaded every day, the amount of data traffic that is carried over wireless networks, as well as number of people who bring their own devices at work, all the indicators are pointing upwards, leading to say that continuous investments need to be made in wireless networks. If we move to the right section of the screen, we're going to have a focus more on in-building deployments or confined areas like university campuses. So today, more and more we're operators mentioning that as high as 80% of the traffic comes from indoors. Also, still today, there's very few buildings that are being covered. If we look at the large office space environment, it's estimated that less than 2% is addressed today. So there's still plenty of potential to grow in this market. Also, when we look at the continued complexity of the network architecture and the different technologies, very often we're about Wi-Fi, LTE being combined, and there are different means to distribute the signals, whether it's through a DAS, using small cells or access points, and also very often there's a public safety component into the equation. So it could get quite complex and convoluted to deploy these networks. And the last indicator, looking at how operators are investing into their networks, more and more we see that the capital expenditure goes towards indoor networks, as the macro network has been already deployed and is somewhat well positioned. Now that we've looked at high-level metrics from the in-building industry in general, let's have a closer look at market data that belongs to university campuses. So according to the most recent market report that was published by Mobile Experts, it's estimated that more than 20,000 campuses exist worldwide, and these campuses could benefit from advanced wireless services. So this represents a market opportunity of approximately $8 billion US. So, and this opportunity is estimated over the next 6 years, so until 2019. Then, out of this $8 billion US market opportunity to deploy on campus environments, it's estimated that less than 1% of it is addressed every year. So again, this is an industry or a segment of the wireless industry that presents a lot of potential for additional investment. Now that we know what's the total potential worldwide, let's have a look of how the penetration goes globally as well as in specific geographies. So globally, it was estimated that only 0.4% of the total potential was addressed, whereas it's predicted that this figure will almost double over the next 6 years. In fourth position, we find Latin America and Central America with almost just 0.1% of the total market opportunity that is being addressed today. Third comes Asia Pacific with 0.3%, and reaching to 0.4% of the annual market opportunity to be addressed. Europe comes second with less than 1% estimated at the end of 2013. And North America ranks first with a little bit more than 1% and projected to triple, almost triple, over the next 6 years. Now that we know how many university campuses there are and also the penetration rate of each geography, we're going to have a look at how this translates into investments and predicted growth figures per geography. So again, previously we saw the percentage points allocated to the market opportunity. Now, in terms of investments, it was estimated that a little bit more than 300 million USD were invested in 2013, and that figure is planned to a little bit more than double over the next 6 years. So this represents a CAGR, or a compounded annual growth rate, of 14%. Again, in fourth position, we find Central and Latin America with a quite an interesting CAGR of close to 23%. So we're into a growing industry. Europe comes third with close to 100 million USD of investment predicted over the next, by the end of 2019. So these would be annual investments. So that represents a CAGR of approximately 19%. APAC comes second, with Asia Pacific, comes second, with almost 160 million USD investments in 2019. And again, North America it's projected that it will capture almost 50% of the global opportunity towards deploying wireless systems on university campuses. And the CAGR here is approximately 10%. So now that we've established some market figures based on market research, here the numbers came from the latest ABI research report. So once we have a foundation to understand what potential there is globally, we're going to look at some technical challenges that relate to the deployment of Wi-Fi and LTE technologies into these type of environments. And both Patrick and Tisha will be able to share their experience with us. Thank you.
Thank you very much, Dominic. While Patrick is getting ready to begin his presentation, I'd like to take this opportunity to proceed with our first live poll question, which is, how many university campus projects have you deployed wireless networks for? So you have 5 different options to choose from: none, 1 to 10, 10 to 25, or over 50. So please select the answer that best reflects your reality, and we'll collect the responses shortly. Thank you everyone for your input. It looks like the majority of you have deployed actually none, with 52%. So thank you very much for that. With that, I would like to introduce our next speaker, Patrick Lau. As mentioned previously, Patrick is the Director of Business Development for the Americas region at CommScope and qualifies new DAS opportunity in wireless and enterprise markets. He develops go-to-market strategies to acquire new customers and break into new verticals. Patrick has 20 years of experience in the RF telecommunication field and joined CommScope, formerly Andrew, in 2001, and he's been with the company for 13 years now. So now, Patrick, you have the command.
Thank you, Elsa. Thank you for the introduction. And I can see everybody, I hope everybody can see my screen right now. Good afternoon, everyone, and thank you for dialing in. What I wanted to talk about today, using my time, is really the three areas and Elsa was talking about. And I'd like to see overall the LTE market, and I know Dominic was talking about it earlier in his talk, and I like to present it or talk about it, look at it from a slightly different perspective. And as, of course, as OEM equipment vendor, wanted to talk about the coverage options for college campuses when deploying the DAS, and some of the best practices and lessons learned. This chart, I think some of you probably have seen this before, is always very exciting to see that. If we have been in the industry for a while, if you look at the industry projection 10 years ago or 15 years ago or even longer, talking about in-building coverage, people always project that's going to be growing, and DAS will be here. And I think finally we're living on the curve, so it's rather exciting. As an industry, and I think we have reached a very significant milestone. That is, if you look at the chart at the end of 2009, and the demand for the data services has finally surpassed the demand for voice. And the growth and increase of the data and has never really stopped. Part of the reason, and if you look at the LTE as part of the data, it really has been unparalleled in the wireless industry. And the 4G and the 4G technology is facing unprecedented capacity demands. We know LTE today is a data service only, but I know carriers and other OEM vendors, they're active development and to deploy voice over LTE or VoLTE. And that will eventually allow the operators to replace some of their legacy technologies from their spectrum. And at the end of the day, I think eventually the operators would like to use LTE for both their voice and data in their network. The exponential growth, and I think if you look at this trend, and also is directly linked to the change of the data usage pattern of our mobile users and compared to earlier technologies. What I say that is because if you look at this, there's a clear difference in the data usage pattern between 3G and 4G subscribers. In a recent study, that was estimated that LTE subscribers use 168% more of the data, mobile data, than 3G subscribers. As more of the subscribers they're moving to 4G, the upward trend of data demand should also continue. And I think the primary reason for this is really because this continued nonstop development of content, applications, and users' devices, the smartphones and tablets and different brands. As an example, the viral YouTube video, for instance, and gets shared on the Facebook or other social media, and millions of users can access the video in a very short period of time. The one thing came to mind is recent. If you're on Facebook, it's hard not to see the ice bucket challenge. Everybody is calling out everybody and try to do it, and people that are watching it, and they take a lot of strings on the mobile network, and that's because of video and video chat. It takes a huge amount of data capacity from your mobile network. And also another interesting fact that I read from a report, back in 2011, 6% of YouTube traffic was from the mobile devices. Fast forward to today, that number has increased to more than 40%. Besides the LTE demand, as it's tried to satisfy in the macro or outdoor network, operators also facing challenges in meeting the customer's expectations in some of the larger venues for indoor. The venues such like the sports stadiums, airports, college campuses, sports arenas, and so forth. And it's estimated that clear majority, up to 80% of the mobile data connections take place inside the buildings. As businesses rely on mobile devices and their data services as their primary business data service. And I think it's not really surprising to see everybody, if you look at people, they have the phones and have the tablets, and that brings to another really a driving factor, that's bring your own device, BYOD. That's a policy being adopted by most corporations that will allow the employees to bring their personal devices to access companies' network using a VPN connections. I think it's especially true in the college campus environments. As college students, they use smartphones and tablets as their primary communication devices. And I will venture to guess the penetration in that particular demographic, it's far more than 100%. That would mean, on average, and each student will have more than 1, 2, or 3 different their devices. How would you like to address that? As we all know, in-building coverage solution itself is not new concept. For the people who are new, the audience is fairly new to the industry. 5 or even longer years ago, when we were deploying and in-building solutions or distributed antenna systems, it's more focused on the voice. Remember the curve we're talking about, the data has finally surpassed and the voice demand. Nowadays it's more for data or high demand in data services. But DAS is simply a network of different antennas distributed throughout buildings to provide improved the network performance. And various amplifiers, what we call the different remotes, are typically connected to the DAS head end in the equipment room with the base stations and ENOBs and via single mode fiber cables. Most DAS installations today, including CommScope's ION series, support multiple bands, multiple operators, and multiple technologies in one platform and infrastructure. College campuses. That represents a very interesting opportunity for us. As you can see in the map, it clearly requires both indoor and outdoor coverage and capacity because they have a different shapes of the buildings and different sizes, and you do have outdoor areas. As we know, many colleges that were built a long time ago, and hundreds of years ago, now hundreds of years ago, and the buildings are beautiful ivy-covered brick structures. Even with some of the new ones, and some with the energy-efficient low-E glasses, and aesthetics are very important. So mounting multiple antennas for each individual wireless operator is impractical. We believe the neutral host DAS solutions is the most acceptable approach in the campus environments because the different size, because different capacity and the shapes of the different buildings, and it's because these are serving for different purposes. And I think their coverage and requirements are also different. You have to believe that design for each type of buildings should be also different. Some bigger schools, I mean, they have a really big sports teams, and we look at college football stadiums. Some of them, they have similar seating capacity of professional football stadiums. And our design approach for these type of college stadiums is the same as any large stadiums. What I mean by that is we're using the low power and high power remotes in the design as a kind of hybrid. We usually use the low power to cover the seating areas and the parameters within the stadium, and we use the high power remotes to cover the parking lots, give you or cover bigger areas and probably fewer sectors. Now here's the zone and sectors. To some of you, maybe that's a newer concept. What does really zone mean? In our definition, DAS is typically designed in zones because it allows any operator and technology to combine as many zones into sectors as needed. It doesn't have to be the same for all technologies or all operators. For example, LTE typically requires more sectors than 3G or 2G technologies. It is important to note the total number of zones is the maximum number of sectors that a DAS can accommodate. Let me try to repeat. The total number of zones is the maximum number of sectors that a DAS can accommodate. What I mean by that is because usually in the stadiums like there's a highly concentrated areas capacity. This is for neutral host, multi-operator solutions. And each operator, you have to believe they have a different capacity requirements. In a particular venue, say you design a venue for 20 zones. That would mean the maximum number that operator can have, the capacity requirements, is for 20 sectors. You can have fewer than that, but for this design, you cannot have more than 20 sectors. If you do have 20 sectors, that would mean each zone will become one sector. That's one-to-one mapping. If you have, say, less than that, say 10 sectors, and then you would combine 2 zones into one sector, and so forth. In the cases, which happens from time to time, if you outgrow your capacity, the required number of sectors to outgrow the number of zones, that usually what happens, you need a major upgrade where redesign effort will be required. In a DAS, it's critical to design the system for enough sectors to ensure that system will support the growing data demand. We have seen the number of sectors doubling every couple of years in similar size of venues and designs. We have also seen the venues are completely being redesigned just because simply the design or the demand for the number of capacity or number of sectors outgrow the original design. We're talking about the sports venues or sports stadiums on college campus. That's only a portion of the college campus. The rest of the campus would take the approach as a hybrid approach. It's using the solution outdoor DAS to cover from outside in. What I mean by that is using outdoor high power remotes to cover the most outdoor areas for all the outdoor areas and most of the buildings. We strategically choose the node locations and mount the high power remotes and high gain antennas on light poles or utility poles to cover the outdoor areas and the buildings, such as academic buildings, student unions, or residence halls, research laboratories, and so forth. And you try to do that, and it's make it aesthetically pleasing, and the form factor is important, all the different factors you have to consider, and I think our Tisha will mention that and in her presentation later. Now, in the case we're talking about the buildings were old or built many years ago or hundreds of years ago, and for physical structures you can't get the coverage from outside in, and from a DAS perspective you build a separate indoor DAS or low power to augment the coverage from outside, and that will be required also a neutral host approach to cover the multiple operators and the frequencies and technologies. What is visible to the end user, that will be an indoor antenna similar to what you have seen on the screen, the upper left-hand corner of the slide. Of course, there's other things we're talking about, and for the purpose of this discussion, we're talking about distributed antenna systems. Of course, people probably, the audience may think about using Wi-Fi as another approach to cover that. It's certainly, this is one of the methods to do that, but if you want to talk about the ubiquitous coverage for the entire campus, outdoor and indoor, that's how we augment the coverage inside the building from the outside. So what is the lessons we have learned? Is the different areas, and I think I will look at it from 2 different perspectives. One is the existing DAS on college campuses, and the other one is this new one. If you build a DAS in certain areas, it's legacy systems, 5 or longer. Chances are that's a 2G, 3G network. And those of the installations will not be sufficient to support LTE without modifications for the following reasons. A lot of people, they think, you know, we're trying to, or some would think we can upgrade the 2G, 3G to LTE. We simply add another run of the cable, make it a, you know, path 1, path 2, make a MIMO approach. Certainly that's one of the approach, but we also have to consider the capacity and the quality of the network from the legacy design. For one, you have to evaluate, are there enough sectors to support the data demand in LTE? And also we know the 2G, 3G technologies were also a lot more tolerant on sector overlaps, uplink noises, and other parameters than LTE. So you have to evaluate that sort of things before you can say, okay, just simply add another run of the cable, then we can call this LTE compliant. Another area we look at is a new DAS, is a brand new system you wanted to build. And I think the lessons learned or experience that we've had is to plan ahead. We talk a lot about the relationship between the zones and sectors, and for that is you want to plan to have enough zones in certain areas, especially the highly concentrated venues or areas. Make sure you have enough the zones in the design so you can foresee any new future growth to accommodate the growth for the data capacity requirements from the different operators. One example you can look at if it's a stadium or highly concentrated to high areas, using the college stadiums as an example. But there are a lot of sectors inside the stadiums and the seating areas, then the outside of the stadium, which is the parking lot. In some cases, we put in a transition zone between the two to ensure the continuous coverage and the smooth handoff between when the user going from in to out or vice versa of the stadium. The rest of the campus, like I said before, and I think the most cost-effective way to do that is a hybrid design using outdoor high-power coverage, the rest of the campus, and coverage from outside in, and to augment the coverage inside the building in case when you don't get it from outside. And finally, deploying LTE over a DAS requires careful consideration in system design, installation, commissioning, optimization, and monitoring. The more intelligent the system is, the smaller the likelihood of error is in any one of these phases of a DAS project. We at CommScope have recognized this opportunity, and we're striving to present products that make it easy to deploy LTE over DAS. I think if that's the time I have, that's all I have. And thank you for your attention. For now, I'm going to turn over to Elsa.
Thank you very much, Patrick. We now proceed with our second live poll questions before Tisha starts her presentation. And the question is, in your opinion, how often, in percentage, is Wi-Fi deployed together with licensed spectrum technologies? So once again, you have a few options to choose from. So we'll just leave you a few seconds to think about that, and we'll collect the responses in just a few seconds. Time is up, and the results are in. And it seems that the majority of you opted for option 1, which is between 0 and 20%. So once again, thank you very much for your input. With that, I'd like to introduce our final speaker, Tisha Wilson, who is the Area Manager, Construction and Engineering for AT&T Antenna Solutions Group. Tisha manages a multi-million-dollar network capital budget and is charged with delivering customer solutions to large public venues and enterprise buildings. Tisha was appointed to this position in June 2012. Prior to that, Tisha has enjoyed a variety of assignments during a 17-year career, including the creation of the architecture for alarming and monitoring of DAS installation across the country. She's also held various technical and leadership roles in UVerse and operations, supporting AT&T's signature large business client base. So, Tisha, it's over to you now.
Good morning and good afternoon. Thank you very much for that introduction, and thank you all for joining today. So, quick question. Think about this while we're going through this presentation. Do you have children, nieces or nephews in college? Are you likely to get a phone call or a text message letting you know they're okay or if they need more money? I think the answer will probably be you'll get a text message instead of the phone call. Today we'll talk about, here we go, effective solutions that AT&T utilizes for campus environments, our requirements for success, and construction lessons learned. I'll cover what we actually do, what we think about, how we manage through being successful at various locations. So what you see here is the approach, or what we look at when we go into a campus. So what does this mean? We look at what is already there, what's existing, what coverage and capacity is being cared for today, where do we need to fill in the gaps, and you've heard the other speakers talk about the outdoor in, or the outside in approach. So we look at what macro is supporting a venue or a campus. Is it enough? Are there drop calls? Is there a low data throughput? If there is, where can we fill that in? And we may look at doing an outdoor DAS solution. Then we look at, okay, after we've done this outdoor DAS solution, is it penetrating the buildings enough to provide more support inside? If it's not, then we may look at an indoor DAS solution. In another presentation we did, there were several questions around Wi-Fi. One of the things that I want to point out right here, that's one of the questions on our survey when we go into a venue or go into a campus. Do you have Wi-Fi? What is that coverage like? What is it? Where is the coverage? Where does it need to be augmented? And again, we will look to see if an indoor DAS solution is the best solution. So why would we decide on a DAS? Why, after we do all of these various studies, what is it that makes us go this particular route? There are many applications that are used by students, with 59% of students, according to a recent study, using mobile devices to study with. 93% use study applications. From a general broad perspective, 52% are using applications period on their devices, and we have quite a few people who even sleep with their devices. One of the other things that has increased at schools as well as businesses, Patrick talked about, was the fact that BYOD, or bring your own device, has increased. For faculty members of university and campuses, as well as for the students, bringing your own device to use on the campus's infrastructure, that puts a great tax on, or strain on the existing infrastructure. What does that mean? That means that the IT department for any university or campus really needs to put focus on improving the infrastructure, and whether that is DAS, small cell, or Wi-Fi, that decision must be made. One of the other things that we look at is that currently technology allows students to access online learning tools and interactive resources. So there was a point where if someone pulled out their mobile device while they were in front of their professor listening to a lecture, the assumption would be that they were not paying attention and potentially even playing a game. Today, it's the norm. They're pulling out their device to perhaps use or leverage the interactive resources for their textbook, or to take notes, to record the lecture itself. There are a variety of reasons why this would be the case, and we have to meet that demand. Some studies indicate that students today own up to 7 devices on average. Some of the smaller locations indicate it's maybe around 2.1, so over at least 2 to 3 devices. That's still quite a bit of data that's being utilized on a daily basis. So what do we look at? What are we thinking about when we are going in, targeting the experience for a university. Number one, we want to improve the customer experience. We want to decrease those block calls, low data throughput that I talked about. We want to eliminate drop calls and make sure that coverage and capacity concerns are cared for. This improves our brand loyalty, increase sales opportunity, as well as improve the safety of the users on campus, and therefore, again, improving or increasing customer satisfaction. I talk about security quite a bit here. Faculty members, as well as students traversing through a campus, going from building to building, whether it's at night or in the daytime, we want to make sure that their devices are still able to be accessed and utilized. We want to be able to make sure that they are safe and secure. They can make a phone call in the event of an emergency. That's one of the concerns that we have when we're building a system out. The coverage throughout the campus, we look at what can we place into stairwells, basements, underground parking garages to ensure in these particular types of areas that coverage is really, really available and key for them. We want to improve capacity. That means the number of actual people utilizing the system is greater than what was initially there. The visitor experience, when fans come for an event or alumni event, we want to make sure that experience is good. People will definitely make a phone call or complain if their devices do not work, but they also remember after the 5th time or so, oh, you know, I didn't have a drop call, or my data went through just fine, especially when they hear someone else complaining about their service. They will remember the good experience later. So we talked about the outside-in approach quite a bit. This is what a typical university campus looks like. And we look at, you can see a tower that is trying to provide service to multiple buildings. Again, we try to look at where can we fill in the gaps, go in strategically after many, many studies to determine where we can place where we can place antennas and remotes, and then we do additional studies. We are constantly looking at our systems to see if there is any way to improve, get better, and we do so. We do several modifications throughout the year after we place a system in to get better and provide better coverage and capacity. So I have construction engineering, and one of the things that we talk about all of the time is be prepared, be prepared, be prepared. You're going to hear this theme more than once. I'm going to say it one more time for you, be prepared. One of the things that are what it means and what it starts off with is innovative AT&T senior real estate and construction managers that happen to be good chess players. In other words, they can look at a build and see the finish line before the first nail even goes into the wall. And they make arrangements to prevent issues that can come up during construction. We need qualified suppliers that understand and appreciate AT&T's standards, methods of procedures, in construction. In a recent university build, we installed over 17 miles of coax, over 420 antennas, nearly 5 miles of fiber, and more than 22,000 man-hours went into the construction and optimization of the system. This was not the largest build we have completed, but it displays the thousands of moving parts while bringing it all together at the right time. So preparation is critical. A clean design, a clean bill of materials means a clean scope of work equals a smooth construction and test and turn up. Now you'll see here to the left the equipment and materials. I'll talk about this a little bit more here, where we've learned you must have a really good mechanism to track all of these moving parts. It can be well over 6,000 parts at one location. So again, I'm going to say be prepared. That's part of that preparation. Dedicated resources. We must have people that universities can trust and build good relationships with. In any other venue that we do work in, I believe in a university situation, the relationship of the people on site doing the job is even more critical than any other location. They want to know the people that are on campus with young students are trustworthy and really focused on doing quality work. I talked about a clean design, a clean bill of materials, a clean scope of work. That means delivered to the suppliers, mitigates quite a bit of foreseeable problems. Communication is another thing that's also very critical. Communicate early and often, and keep all stakeholders informed of progress. Sometimes by sharing issues with others, it'll lend to a creative solution to a problem that was not derived by a single person, but multiple people providing input into solving a problem. Now, one of the other things from a logistics perspective, when we go into a venue or into a campus, we provide the standards and the requirements we need in order to be successful. For a DAS, you must have a head-end that will allow you to place in base station equipment, your DAS head-end equipment, your power plants, DC, we use DC as a standard across the country, and battery backup. And for universities and campuses, we ensure that we have a 4-hour battery backup. With that being said, we also need additional space with IDF closets across the campus so we can place remotes as well as additional power needs. Now, on the other hand, with Wi-Fi, it does have a smaller profile because with DAS, we're installing coax as well as fiber across the campus. With Wi-Fi, it's typically fiber, some APs, a smaller footprint from a head-end perspective, and a smaller remote footprint with placing the APs in any downstream power needs. So it's a good partnership when you look at a campus location where we can go in, place the equipment needed to support the DAS, and then go into locations where you might not want that intrusive infrastructure and place in Wi-Fi. Again, it can be a beautiful marriage when it works well. So, in summary, requirements, standards, methods of procedures being clearly communicated to our suppliers, our standards and requirements for success being clearly communicated to the universities and campuses, good people on board that are highly organized, technical, and can foresee problems and prevent the problems from ever occurring is critical to our success when installing at a university or campus. Thank you very much for your time today.
Thank you very much, Tisha. Before we jump to our final Q&A session, we have time for a third poll question. So our question now is, according to you, how much has mobile data traffic increased since 2007? So you have a few options, 25%, 100%, 200%, or 50,000%. So once again, we leave you a few seconds to submit your votes, and we'll collect and share the responses with you shortly. Thank you again to everyone who submitted the answers. It looks like most of you have selected the final option, which is 50,000%, which is actually the correct answer. So we're now ready to take questions from the audience. We've already received a couple, but if you haven't already done so, now is your chance to submit your own by using the question box in your GoToWebinar control panel. So let's begin with the first question, which is which are the, this question is for you, Patrick. Which are the issues linked with deploying Wi-Fi together with DAS?
Thank you, Elsa. That's actually a very good question. It's not a straightforward answer. Forgive me for not giving you just one-line answer, because that's the question whether Wi-Fi and DAS, how should we deploy them together or separately. And I think in the industry we have a lot of debate for the past several years. And to us, it's not really a technology issue. A lot of it is more of a cost. It's overall most cost-effective solution, because if you look at the frequency in general, the Wi-Fi, either A, C, and G, and B, and 2.4 or 5.8, and because the nature of a propagation loss, the free path loss, and that the antenna, and also requires a higher data throughput, you have more of a dense antenna throughout the building or venue, and compared to the commercial services. And some of the studies were designed as examples that we have seen that requires antenna density for Wi-Fi deployment is twice or even 3 times compared to the commercial services. So if you combine them together, deploy them together, is not the most cost-effective solution to do so. Having said that, and I think it's another issue we need to look at, it's as a user, subscriber, is it really transparent? It doesn't really matter if it's Wi-Fi or from operators, it's LTE services. When you get data, that's data. You care about the reliable services, you care about the throughput. But we need to keep that in mind. Wi-Fi is unlicensed, whereas the commercial services is licensed. When we talking about the services, somebody has to decide whether you provide a free data service or you provide a service with a fee. Because if you do that, and if you charge people for doing that, there's a certain level of services that you have to meet. Therefore, either the building owners, the university campuses, they have to own it, or the wireless operators, like ATT in this case, they have to support and own it. Otherwise, you don't want to put your name on it, and you have to charge people for it, and that's more of a business issue. As an equipment vendor, and we have introduced a new product platform, and it's completely IT-based infrastructure, and it carries both wired and wireless services. And that was introduced in Europe earlier this year. We're going to announce that or launch that in 2 weeks here in North America. And that one, we can, in that particular product platform, we carry the commercial services in addition to that, and actually will provide and carry the IT data path. So you can combine them together with the same cabling and also the same device. So, but again, the answer is whether you need to combine them together, I think is more of a cost issue, not necessarily a technology issue. Thank you.
Thank you very much, Patrick. Tisha, did you have anything to add to that?
You know, I keep saying or using the word marriage. Again, it's the construction constraints as well as the cost. So if it's a location or a building that the landlord, or again, the university says you can't go and put this huge system into, or you can't go into the walls, or you have to go into the ceiling. These are some of the other concerns from a construction perspective that you must look at when trying to marry the DAS with the Wi-Fi.
Thank you very much. Our next question is for you again, Tisha. What would be the anticipated lifetime of a DAS system installed today?
So we go in after studying the market, the area, the use of a location with a 3-year projection. But we're constantly studying the venue, the campus, et cetera, to see if there are any changes in usage. We look at technology changes as well. So we actually, in reality, go back typically every year to make sure we're up to date. We're not really needing any additional changes, and we will make adjustments. For example, there are spectrum changes, so there are additional carriers that we'll add, And that is typical to see after we've gone in and done the initial installation, because that particular market may not have the carrier available until later. We look at the capacity. If today the use case stated X and we projected a growth of, let's say, 5% over the next 3 years, and we discover that there is a 15% increase in the use the following year, that means we need to readjust and increase capacity a lot faster than the projected 3-year period. The equipment itself, if it's installed right, if it's installed utilizing the standards, if there's caution made when handling the fiber and the coax, it can literally last for many, many years. We've found locations that have had the same equipment installed for 9 years, 10 years, still working. Now, is it providing the performance you would like? Maybe not. But from a life cycle perspective, the equipment itself is sturdy. Our challenge, our biggest challenge, is meeting the coverage and capacity needs of the venue. And that's the thing that you will see with changes being made. It's not because of the quality of the equipment, it's really because of needing to meet the demands of the campus. I hope that helps.
Yes, it does. Thank you, Artisha. Artisha, another question for you. Somebody says there are other alternatives to using a DAS for these type of deployments. Alternatives that could be more cost efficient, like using picocells or small cells. What's your opinion on that?
This is very true. As a matter of fact, that's another part of our business unit that with the increase in data, we're constantly looking at how do we also be more cost efficient when doing these installations and less intrusive from a construction perspective. So small cell, currently what we're deploying is the UMTS and HISPA Plus, or HSPA Plus, excuse me, and we're expanding that with UMTS, the HSPA Plus, LTE, and Wi-Fi. So I believe that we will see it will be a dominant technology of choice when we are looking at our densification program. So that is something we need to look at, getting more efficient in our installation with. And then from a Wi-Fi perspective, again, that's another option for installation if we can really get the cost of installing the fiber down to something manageable. The APs, deploying them throughout a venue, again, not as intrusive as a DAS, but small cell is something we're very, very focused on from a company perspective.
Thank you, Tisha. We're running out of time, so we're going to take 2 final questions. So the first one is for Patrick. Patrick, what have you learned from deploying neutral host DAS in college campus environments?
Thank you, Elsa. That was a good question. We have learned a lot of lessons in doing the larger neutral host in a different environments, college campuses for one. And I think, obviously, the challenges and the lessons learned is in the most complicated, the larger venues and more people and capacity demands. And in those kind of areas, and I think I talked a little bit about that topics earlier, is you have to plan ahead. Right now, the game is really the capacity and the data throughput, all about data. So when you design a system, and in the area, you have to design a system to have a future-proof in mind, whatever that means to the audience here. So you have to really design a system in the foreseeable future to allow the operators to grow into the system expansion. That means probably more zones and more better of the design in the sectors, as you sharpen in the radio frequency, the RF, and where you want to contain certain areas where you want to propagate. That means the shaping, scalping of the antenna pattern and control the overlap. And all those are the issues we have to do. And we're talking about, in some cases, there's a transition zone in the larger systems because there are far more number of sectors inside an area, using stadiums as an example, college stadiums. And when you go in and out, and outdoor is more of a larger area, fewer sectors, and to ensure the continuous coverage and the handoff. And that's some of the lessons we have learned. But essentially, if you have a one word to walk away from this, and really it's plan ahead. Thank you.
Thank you, Patrick. One final question for Tisha. So Tisha, I'm not sure if you're going to be in a position to respond, but let's give it a try. What proportion of AT&T DAS systems are neutral host versus single operator systems? And then what do you expect that proportion to change over time?
So you're asking what proportion of AT&T DAS systems are neutral host, and do I see that changing over time?
That's correct, yes.
So I can't give an exact number, but I can state that our targeted strategy is to go in with a neutral host system. That is our initial strategy with deploying at a venue. It makes more sense for us to go in, and we're finding even with other carriers, they agree. It was not necessarily the case 4 years ago, but today what we see is even the other carriers agree that it makes more sense to go in with one infrastructure and then add on to support multiple carriers versus going in with multiple layers, taking up additional space and infrastructure from a campus. So do I see it growing? Yes, I do. I don't see, as a matter of fact, this year compared to last year in my market alone, it's, I would say, over a 200% increase. So okay. I see it growing.
Good. So basically you see that more and more operators are receptive to sharing the same DAS.
Yes.
Okay. Thanks for your answer.
Great. Thank you very much, everyone. Our time is now over. So I'd like to finish by thanking our three speakers, Tisha, Patrick, and Dominic, for the great presentation, and thanking all of our participants for joining our session today. We do hope that you found it informative, and we invite you to join the iBwave LinkedIn group where you can continue the discussion. Finally, as a reminder, you can look for the webinar recording and the slides in your inbox tomorrow. So once again, thank you very much for attending, and have a great rest of the day.